This chapter in data voice and video cabling, we're going to be discussing video systems installations. Now, in this chapter, we're also going to be talking a great deal about code and code requirements in the installation of coax cabling. Cabling for video applications covers two distinct uses: the closed-circuit TV for security surveillance and television. Now, either cable TV, which stands for community antenna TV, not cable TV, or satellite. Both cable TV and satellite are used to distribute television signals. Both CCTV and television use similar cabling and installation techniques. So we're going to be talking about these two types. The video cabling itself, okay? Video cabling is a high bandwidth of video signals which requires the performance of coax cables for transmission. A coax cable has always been the industry standard for high bandwidth applications, and although it's been replaced by fiber optics for long distance or higher bandwidth applications, microwave transmission is used only where required because its cost is significantly more than the other two methods. Now, using a high quality coax cable is essential. So for CCTV installations of less than 1,000 feet, we can get away with RG59. But for distances of 1,000 to 2,000 feet, you're going to want to use an RG11. Installations of more than 2,000 feet in length require the use of amplifiers to keep the signals at usable levels, or the use of optical fiber as the communication media. Most CCTV installations will use BNC connectors, a bayonet mount connector, or occasionally an F connector, the kind you would see for your cable television. Now, cable TV uses large RG11 or RG8 for its trunk lines, and then the RG6 for its drops to the home and within. A satellite TV uses a similar cable to cable TV or CATV, but operates over a higher frequency range of up to 2.25 gigahertz, while CATV is limited to 1 gigahertz. And since satellite systems use the coax cable for power as well as signal, the center conductor is pure copper, while CATV cable uses less expensive copper-cladded steel. Larger buildings with longer cable runs may use Series 7 or RG11 cable for its lower loss, and the standard connector for CATV is the F connector. That's the one that threads on the end. When we're looking at the installation of cable or CATV, installing the video cabling is relatively simple. Coax cables must be installed with care. That is, they may not be pulled beyond their tension limits and may not be sharply bent. In addition, they must retain safe from physical and from environmental hazards. Care must also be taken when strapping or especially stapling the cables to structural surfaces, walls, ceilings, and so on. If a stapler strap is cinched too tightly, it will deform the cable and then alter the transmission's characteristics. Now, as we talked about earlier, security cameras must be firmly mounted. In addition to standard wall mounting brackets, cameras may also be mounted in vandal-resisting cases, which are recommended in trouble-prone areas. Mountings are also available within the built-in panning and tilting mechanism. Obviously, these will cost a bit more than the standard mounting, but will provide an additional benefit. However, they cannot be used in all installations, particularly not with video motion detector devices. The terminations of our coax include a center contact in an outer shell that connects to the shield of the cable. The CATV systems use the F connector, which is a screw thread connector, whereas CATV may also use a BNC connector, or bayonet mount connectors. The N connector is also used in large coax cables. Note that the F connector uses the center conductor of the cable as a center contact, minimizing installation times and costs. Coax connectors are so simple to install that we all can do and install them all the time. For example, connecting your VCRs. using simple screw-on F connectors. For building wire and coax, especially for CATV, we need to be more careful to ensure high performance and low signal leakage. Compression connectors are preferred, and cables should be of top quality. When making up a coax connector, it is important to make sure that the connector type matches the cable type and that the connection is made up securely. Now, cable television and security monitoring circuits are covered in Article 820 of the NEC, and as we all know, the use of such circuits has expanded dramatically in recent years and is likely to expand much further as the information highway continues to develop. The service that will probably do more to promote high-tech telecommunication service than any other are internet connections by cable modems and video-on-demand systems. Now you will notice in the Article of 820, the Community Air Antenna Television, or CATV, you'll notice because very few of us have ever done a community antenna installation, and because we're relating this article to cable television and security monitoring, the following provides a brief explanation of CATV. Started decades ago as a means of providing television signals to communities that could not receive broadcast stations, either because of distance or shadow areas where the signal was too weak. Community antennas were then installed at remote locations such as top of a building or nearby hill, and the signals were then fed to the homes in the area. Later, when television signals transmitted via satellite became common, cable TV systems were able to provide a much wider variety of programming than was available via the broadcast. Once programming all over the world was available, the demand for the service became enormous, and cable television companies began to provide services. The new services were based on the same standards and methods as the community antenna systems that from which they originally evolved. And today, cable TV has developed into a huge system that serves over at least 40 million homes in the United States and is growing steadily. Security monitoring has also been used ever since it became possible. At first, when the technology was new and costs were relatively high, security monitoring was used only for vital uses. Later, as costs came down, its use became widespread. 820 is therefore very broadly defined, covering all radio frequency signals through coax cables. And although the term radio frequency, often abbreviated as RF, is not defined in the NEC, it would generally include every frequency from several kilohertz to hundreds of megahertz. The article does not, however, cover television cable that is not coax. And the primary safety requirement of the articles are first that the voltage applied to coax cables not exceed 60 volts, and the power source must be energy limited. Energy limitation is it's defined in section 820.4 of the NEC itself. Grounding is mentioned in both parts B and C. Grounding is strictly required for coax cable runs outside of buildings. Although the NEC does not specifically state that all outdoor cables must be grounded, almost all outdoor runs must be grounded to meet requirements of the article. And the concern with outdoor cable run is that they will be exposed to lightning strikes, and in addition to direct strikes. So outdoor runs of conductors can have substantial voltages induced into the conductors from nearby lightning strikes. Another concern for grounding is accidental contact with power conductors. Whenever an outdoor coax cable could accidentally come in contact with power conductors operating at over 300 volts, once again, grounding would then be required. So, simple rules for grounding. Cable must be grounded as close to the cable's building entrance as possible. Conductor must be insulated. Must be at least a number 14 copper. And ampacity must be at least equal to that of the coaxial sheath. Conductor must run in a straight line to the grounding electrode, and grounding electrode can be any suitable type. Surge suppressors not required but are practical necessity for virtually all outdoor runs of coax. The suppressors are usually called protectors, and in the communications industry, uh, these devices, which are made of sintered zinc oxide particles pressed into a wafer and then equipped with connecting leads or terminals, have a more gradual clamping action. Clamping is the act of connecting a conductor to a ground, and then the voltages rise to ground when the voltage rises too high. Then either spark gap arresters or gas tubes. Once more, here we have uh, where we route our cable. Cable must be run below power conductors on the poles. So if you take a look at the streets outside, you will notice that there are two separate levels on the utility poles, and the top level is usually your electrical level, and then the one below it would be your cable and telephone. So coax cable must be run below the conductors of power poles. They remain separate from the power conductors at the attachment point. They have an 8-foot clearance, vertical clearance, which means your trucks won't hit them. They must be at least 4 inches from power cables and not interfere with other circuits. And be kept 6 feet from lightning protection conductors. Messenger cables, okay. Majority of outdoor runs of coax cables are messenger cables, or uh, are specifically designed to be messenger cable assemblies themselves. The only requirement made for such runs is that the runs be attached to a messenger cable that be acceptable for the purpose and has enough strength for the load to which it will be subjected, such as the weight of ice or snow or wind tensions. The indoor circuits that we're going to be discussing, coax cables that are run indoors are subject to these following requirements. They have to be kept away from power or class 1 circuits. It can be run in the same raceway as a class 2 or 3 circuit. They may not be run in the same raceway or enclosure as a class 1. These are your higher electrical circuits. They are followed to be run. They are allowed to be run in the same shaft as a power and class 1 conductor, but in these cases, they must remain at least 2 inches away. The different type of cable types that we have are the CAT VP, which is plenum rated cable, P for plenum, and may be used in plenums, ducts, or other spaces. CATV-R, R is a riser cable, extremely fire resistant for runs in installation and shafts or from floor to floor in the buildings. The type CATV is a general use cable, can be used in pretty much any location except for risers and plenums. And then CATV-X is a limited use cable, allowed only in dwellings and in raceways. You will find in practice that many coax cables are multiple rated. In other words, that their jacket is tested and suitable for several different applications. Substitutions that we might find. The code will define a clear hierarchy of cable substitutions. The highest of the cable types is plenum cable, and it can be used anywhere at all. The next highest would be the riser cable, the CATV-R. And the third in the list is CATV, which can be used anywhere except in plenum or risers. Last will be the X, which can be used only in dwellings and in raceways. As always, only plenum types of cables can be used in plenums, riser types in risers, and so on. And I told you this is going to be a short chapter, so be prepared to do your chapter review. In summary, various types of coax cables are used for video systems. Larger cables are used for the main trunk lines, and smaller cables for connections to buildings, normally called drops. Cables must be properly attached, or must be properly matched with conductors and installed with reasonable care. Cables installed outdoors must be grounded and installed with care, especially if they're installed in the vicinity of electrical power cables. Specific rules must be followed when installing your cables. And that concludes our Chapter 6 video systems installations. Next, we'll be discussing in Chapter 7 network cabling, which is the primary purpose of this course, and that one is going to be a considerably longer video, might even take 2. So we'll see how that one goes. All right, see you soon.